Then this aluminum oxide. This one is the same like what we did just now, dehydration. If I don't have porcelain chips, I can use aluminum oxide. And you must heat the aluminum oxide.
Oh,
If this is ethanol, so gas R labeled here.
alcohol,
Gas R is ethene.
hydroxyl.
P is propanol. Okay. And then we have ethanol undergoing, I think there's a mistake here. Satish, what's the mistake, Satish? What's the mistake here? Satish, can you identify the mistake in this diagram, this part here? What is it? Quickly, Satish, don't waste time.
Dehydration.
Dehydration is here. I'm talking about.
Oh, sorry. I don't know. Sorry.
What is it? Anyone?
Oh, complete combustion.
Complete combustion. Write it down here, above here. Complete combustion. Combustion, if you just put combustion, maybe somebody will say it's incomplete. So must be complete. And then, of course, the gas must be carbon dioxide. Carbon dioxide and water, but the gas here is carbon dioxide. So you see, you can put here gas Q plus water. Okay, we have done that before. And then this ethanol, this is an oxidizing agent. Put bracket here, OA. Heating under it. Okay, so ethanol becomes this one. This is, can you see? It's ethanoic acid, CH3COOH. You add up everything and see C2. Okay, put a note here. This is oxidation. This reaction is oxidation here. And this compound T is ethanoic acid. You can identify all from the flow chart, then it's much, much easier. Okay, ethanoic acid. Okay, ethene. Remember here, ethanol becoming ethene. Polymerization. So polymer S must be polyethene. Or polyethene also. Remember we learned that, polymer. Okay. Then this one here, ethanoic acid. Ethanoic acid. Yes, something. Yes, what is it? Darshana, can you mute your...
Sorry.
Darshana, please. Okay. All right, mute your handphone, please. Okay. Thank you. All right. So this is ethanoic acid, T. Okay. I will zoom in, then we check first. Okay, ethanoic acid. All right. You can see here, heating under reflux. You add a compound P to ethanoic acid. So this compound P is an ester. So this reaction is esterification. Let's write it out above here. Heating under reflux also. Esterification. So once you have written everything there, then it's very easy for you to answer that. The flow chart, they covers all the homologous series in one question. You can do that. Okay. Okay, now we jawab soalan. Are you ready, all of you? Okay, I think I'm done. This one is, okay, what is the name for this reaction? Jaing, what's the name for this reaction? Glucose with yeast forming compound P. Cepat.
Fermentation.
Okay, very good. Well done. Write down here, fermentation. Yeah, so I named all the, okay, this is complete combustion, fermentation. This one is dehydration. Same like using porcelain chips. Aluminum oxide is another substitute in ganti. One year they asked, if we don't have porcelain chips, what can we use for dehydration? So aluminum oxide powder. You have to heat, Okay. All right, now we answer, okay. Compound P, you can see, okay, make it slightly smaller. Compound P, all right, this one is produced by fermentation of glucose, okay, in the present. Name the compound P, of course, okay, I want name. So write the name, ethanol. They ask for name. They ask give a chemical formula, write the chemical formula. Follow the question. Name means name, Okay. All right, then combustion of P. In X, they gave you a guide here. They put their excess oxygen. Combustion of P in excess oxygen produces gas Q. So what's the gas Q? Name, again, name gas Q. So carbon dioxide. Okay. They didn't ask for chemical equation, no need. Okay, name compound T now. Okay, this one, P becoming, this is acidified, so this oxidation. So compound T will be ethanoic acid. Ethanoic acid. Okay, done, So I did that day. What is the function of acidified potassium dichromate 6 is orange in color. So it's an oxidizing agent right now. What is the function? They are also oxidizing agent. See, very simple. Okay, what is the color change? I told you, be very careful. SOD5 potassium dichromate 6, and it is orange to green, you know. Note it down. Orange to green. Color change, yeah? Then name the ester form. Okay, now they put P and T, no. So of course, you see, we take P, P and T to form ester. Okay, P is ethanol. We have done this, ethanol, and then T is ethanoic acid. Okay, tell me what is the name of the ester. Who wants to try? Dongsin, you try. P is ethanol. And you see, P is ethanol, this is ethanoic acid. What is the name of the ester? Try to think. Dongsin or Sandra, one of them try. Try to recollect. P is ethanol. T is ethanoic acid. So you champo these two, this sulfuric acid is the catalyst. Okay, you're going to get an ester. Sandra, want to try? Ethanol and ethanoic acid. Come on, I've done this with you. Well done. Okay, very good. So the ester is ethyl ethanoate. Okay, write down. They ask for the name of the ester. Name the ester. Ethyl, ETHYL, then ethanoate. So I think very simple. Okay. Then gas R changes to, okay, gas R is ethene. That's how I showed you. Okay. This is polymerization. Okay. So name the polymer as polyethene. Okay. This one you might wonder, what is this? Never learned before, huh? Okay, this is K-Bart question. You apply what we have learned. Okay? So I want you to take a red pen or something like that. I'm going to show you how you do it. No, it's not so easy. Okay, I'm going to use my. You see, Okay. So okay, let's see what is the question asking us first. The question is asking you, draw the structure of the monomer. This is a polymer, you know. So I want you to identify what see, you might say, I never learned all this before. So Kala never taught me before. How come suddenly he's giving? This is application of what you have learned. Understand? They can ask that. This is K-Bart, SPM. Okay, so what we do is, we do this, Okay, I want you to identify the repeating units. What is repeating? Can you see here? Okay, that's actually this one is like a line here. There's a line there. Can you see? You can just go on the right side, can go on left side. Okay, identify the repeating units. This one is actually, they purposely put it actually C2H5. The Gabong, this is C2H5. So one repeating unit is here. Can you see? Then it repeats here. Can you take a ruler and draw a line? There's another repeating unit. So there are 3 repeating units. Understand or not? There are 3 repeating units. The question is asking you to draw the structural formula. Okay, you don't have to draw the full one also can. Okay, So this is going to be your monomer. This is going to be your monomer. Okay, when you draw the monomer. Just take one of them. Is that clear? I'm going to do it here. So you can see clearly. Okay. First thing is, can you see the carbon here? All right. The single bond becomes a double bond. Okay, these 2. Do that first. All right. It's another color. Okay. Then you see this one here, this CH3. So you must write the CH3 very clearly. The bond must be with the CH3, with the C. Can you see that? You don't put like this, you know. Like that in the middle, like that. That's wrong already. The bond. Yes, Satish?
How did you get the double bond?
Because I told you, whenever polymerization, the double bond, this is a polymer, Satish.
Oh, okay.
The monomer is always a double bond. Then the monomer, when you form polymerization, the monomer becomes a single bond. The double bond becomes a single bond. Remember that? Okay. So then this is your CH3 here. Can you follow me? Okay, this is your H here. So these 2 actually you can gabong becomes, you can put straight away like this. C2H5. So this is your monomer. CH3, C2H5, this one, C2H5, and then this is your H. You follow me? So they can give you a polymer and ask you to draw the monomer. The monomer must have, all right, it's an alkene actually. It's got a double bond there. Okay, is that okay now? So don't panic. It's just application of what we have learned. We did polymerization of ethene to become polyethene. We did polymerization of propene to become polypropene. This one is, 1, 2, 3, 4, 6. It's polymerization of hexene, polyhexene, one of the isomers, one of the polymers. But make sure the monomer must have a double bond, and there must be, this right side, left side must be cosome. When you draw the monomer. Okay, can I continue? All right, that looks ready, I want you to draw this so you know which is the repeating unit. From the polymer, you can identify your repeating unit. Okay, continue next page. So they ask you to draw a structural form monomer. Okay, let's try one more, another flow chart. Okay, let's try this one first. Okay, you try first. They gave you start with butene. But1 is butene. Okay, going to P, forming butane, polymerization, porcelain chip. This one is two-way reaction. Okay, ready? Another flow chart. Okay, read the question. Butene can be converted to butane. Remember, butane to butane. Doesn't matter one butane or two butane. Okay? Through the addition reaction. Can you see? What are the conditions? Okay, who wants to try? Alim, apa the condition for... give me the name for this reaction first. What's a special name? Butene becoming butane. Alim? Alim? What's a special name for this reaction? Alim? Bulan puasa dah lupa semua.
He answered in the chat there.
Oh, he's answered in chat. Oh, sorry. Microphone. Oh, I think microphone has a problem. Okay, sorry about it. Hydrogenation. Well done, Alim. Okay, butane becoming butane, hydrogenation. Okay, so what are the two conditions? Alim, tell me the two conditions. Ataupun Jaden, give me an answer. Is Jaden here now? Tell me the answer.
Tak tahu.
Condition, come on. Try to remember. Butane hydrogenation. I done the flow chart with you. One flow chart, everything I combined one. You have to just revise that. Okay. Celine, try Celine. Celine want to answer? Okay. Halim said heat at 180 degrees Celsius with nickel catalyst. Okay, well done. Very good. Put a note there. You see 2 marks, Heat at 180 degrees Celsius at 1 mark. The maximum 2 marks, don't only get 3 marks. Okay, and then using a nickel catalyst. And this one, actually, what they wanted was butene reacts with hydrogen. Note it down. Butene reacts with hydrogen, 1 mark. Okay. Hydrogen gas, Okay, that's 3 marks. Butene reacts with hydrogen gas. Then, temperature is 180 degrees Celsius. Just mention that. And the catalyst is nickel or platinum. So you get 3 marks there. Okay? Write the molecular formula for butane. Okay, so this is this is C4H8. Okay, so butane must be C4H10. Correct, isn't it? CnH2n plus 2. Okay, molecular formula. You only put N equals 1. That's only general formula you must put. This one just write the formula. Okay, next. Okay, now we go for butane, 2 isomers. Okay, they already told you 2 isomers. Okay, let's try it now. Okay, I want to give you the name also. All right, let's try it now. Okay, the first one is but is 4 carbon. So 1, 2, 3, 4. Okay, put all the H there. This is no need name, but it's a normal butane. N-butane, they call it. N-butane. Okay, first one. Then I told you, isn't it? When you want to draw isomers, the longest chain is 4, you reduce by 3 and put a cabang. Remember I told you, I did with you. Okay, so you put this in number 2 now. Second isomer, only 2 isomers of butane. 1, 2, 3. Okay, and then you put a branch. The branch is your CH3, but when you draw a structural formula, you must show in full. Okay, 1 here. Here is 1, I'll put all the H there. This. Anybody want to try the name? Sean, want to try the name, Sean? British?
Sorry.
Anybody?
Butane.
Huh?
Hmm?
Butane, you know.
Oh,
This, the first one is N-butane, normal
yeah,
butane.
yeah, yeah.
Okay. It's an alkene. It's not an alkene, Sean.
Yeah, no, sorry.
Oh, want to try the second one?
The second one will be no.
Chain is 3. If so, there's a
2,
Chabang.
2,
Where got
propane.
comma? Where got comma? I never
dash
taught you
propane.
comma.
2 dash
Oh.
propane.
Wrong.
2 dash methyl propane.
2-methyl propane.
Sorry.
1, 2. Methyl is the carbon number 2. So 2-methyl propane.
My bad.
Okay, All right. That okay, huh? You can even take a snapshot. Okay. Next page, All right. Now, butane can be prepared from compound Q. Okay. Butane can also react with steam. Okay. See, butane, you see, they say butane can also be produced from steam. Wait. Butane, let me check. Butane can also react with steam. I mean, alkene plus steam. Yes, we can. All right. To form compound Q. Remember, when I did ethene plus steam, what is the name for that reaction? Where you add water. Jaing, you know not Jaing? You take
Hydration.
Are you sure? Hydration. Okay, correct. Sorry about that. Hydration. Well done. Hydration. So hydration means alkene will produce alcohol. So this one you put with steam, that means you're adding with water, it's hydration. So butane with steam becomes compound Q. Yongsin, what's the name of compound Q? I want the name. Tell me the name first before you write general formula. Butane becomes what? An alcohol. So butane will become butanol. Correct? But they're asking what is the general formula of compound Q? All right, to produce compound Q. So butanol, what's the general formula? Okay, now right. Butanol is the alcohol. What's the general formula? All of you right. Marcus, want to try? What's the general formula for alcohol? I've done alkenes, alkanes, alcohol, carboxylic acid, all I've done already. General formulas. Anybody want to try? Celine? Celine, try Celine? Or anybody? Come in, are you there? Come in. What's the general formula? Alcohol.
What is it? The general formula for alcohols.
Because that is compound Q lah. So I want general formula. The question asking what's the general formula. So give me the general formula quickly.
Not sure.
Yashwan?
CnH2n plus 1 OH, where N equals to 1, 2, 3, and so on.
1, 2. 1, 2, 3 wrong is 123. You know, you have to be careful. 1, 2, 3, dot. Must put a comma. Okay, well done. Very good. Okay, now structural formula. Okay, for P and R. Kita tengok what is P. P is here. All right. And R is polymerization. Okay, they want structural formula. So P is what you know, butene reacting with bromine. Okay, anyway, what's the name for this reaction? Butene with bromine. What's the name for this reaction? Anyone knows? Elisa Lee, what's the name? What's the answer?
Bromination.
Bromination, very good. Okay, and this one is polymerization. So, okay, so you're going to form compound P. Compound P is C. Okay, so with the chemical formula is C4H8Br2. Okay, that is your compound, C4H8Br2. So, but they want structural formula. Can you see now? They want structural formula. This is C4H8Br2. Okay, can you draw it for me now? Double bond is all broken, Okay, so 1, 2, 3, 4. Okay, do that first. You can put the Br anywhere, but Br must be first and second only. Because the double bond is here, it comes and attacks here. So this is one Br, another Br. Okay, the rest all, you put your H. Exactly, they're quite strict with it. You put one BRA, another BRA cannot, because where the double bond is, the BR, one BR will come here and one BR will come in and attack. I showed you the last time. Okay. They don't even want, sorry, C2H4BR2, sorry, yeah? They don't want the name also. Anybody want to try the name or not? Satish, give me the name, Satish. Don't ask. Anyone?
Compound P.
What is what's the name for this? I've already drawn for you already. Okay. It's all H. Okay. What is the general formula? No, the name. Anyone? Alicia Ong?
Is it 1,2 dibromo ethane?
No, my dear, 4 carbon one. So dibromobutane.
Oh, sorry.
Yeah, very good. Well done. 1,2 dash dibromobutane, because there's 4 carbon. They won't ask lah, huh? They just have to draw only. Okay, now we go for compound R. Okay. It is polymer, polymerization. Okay, so butene has got 4 carbon in it. How to draw? Okay, I see butene like this. 1, 2. This but 1 in, be very careful. Tengok sini. This one's kebat, in case they ask. Can you see here? But 1 in. Can you see that? Okay? So, okay, I'm going to show you how you do it. Wait, I do this first. This is not so straightforward. Okay, but 1 in and 1 here. 1 H here, 1 H here. Remember? Then H, 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 H. Isn't it? I told you whenever you want to show polymerization, all right, okay, see where the double bond is. So it's going to be like this now. Just listen first. We are drawing the structural form of the polymer. I draw the monomer first. Okay. The but 1 in first. Okay, see this H here, 1 H here. I'm going to put H here, and this H comes here. This side all empty, understand? Okay, so then comes this one. This 1 H here, isn't it? This H I'm going to put here. See this 2? This is 1, 2, 3, 4, 5. Correct or not? Okay, so I'm going to put here C2 H5. This is actually the monomer. Okay, so I'm going to padam here now. I'm going to, so I want equation of the polymer form, the compound form. So this is the same thing. So what you do, you take the same thing, all right? You draw this now. You put a bracket there where I padam. This one I don't need. Okay? You put a bracket here. All right. The end comes here. This double bond becomes a single bond. So I'm going to padam one of it. Oh, sorry. That double bond becomes a single bond. Okay, now you draw it. This 1 carbon here. Put 1 H here. Double bond becomes a single bond. And then you must draw a line like that and a line like that. This is how you do. This kebat. We have already learned how to draw a polymer for ethene and propene, isn't it? Okay, so now instead of this, I ask for butene. This is the polymer. What you drew just now was monomer. This is kebat. Okay, can I continue quickly? We take a snapshot also again. Don't forget the end. The end must come down and then a bracket there. And then you put a line. The line must come out. You count and see carbon 1, 2, 3, 4 here. So 1, 2, 3, 4. Okay. Can I continue? Right. Then this one is next question. Table 3 shows the result of a test to distinguish or to Bezelkan between butane and butene. Both also gases, Okay. Butane and butene are both gases. Ready? Okay, so explain why there is a difference. Can you see now? Okay, let's check first. Acidified potassium manganate is added to butane. Purple color remains, no change. Acidified potassium manganate is purple. Acidified potassium manganate is either butene, purple color, this color, right? Why is that different? Only giving 1 mark. So you just say butane is a unsaturated hydrocarbon, while butene is a saturated hydrocarbon. I repeat again, butene, put butene first, B-U-T-E-N-E. Butene is unsaturated hydrocarbon. Unsaturated is a double bond there between the carbon. While butane, B-U-T-A-N-E, is saturated hydrocarbon. That's how we explain. I repeat again. Butene is unsaturated hydrocarbon. That's why it changes color. From purple to colorless, or the bromine water will also, become change color. But instead of adding bromine water, we add acidified potassium manganate 7 can. Okay. Then let's go next part. This one is very popular now. And you see, they gave you, okay, this one you must, usually what they do, they will ask you to, okay, take out a calculator now. Get a calculator ready, this is another one, This is another test in which kita boleh bezakan between an alkane and alkene. How to know? Okay, you see, when they give you, they'll give you all the same number of carbon. Okay, butane, okay, I'm going to write the chemical formula. Okay, butane is C4H10. Okay, C4H10. All right, and this one is butene is C4H8. See, when they ask you to compare for the flame, which is more smoky, all right, they will give you the same number of carbon, but hydrogen different. One alkane, one alkene. Okay, they will put a filter paper here. If you don't put the filter paper very close, then you'll get burnt, You just put above here at a certain height. So the flame, the smoke, it will produce a very smoky flame. And here also very smoky flame. So then you look under the filter paper, you can see it's like a layer of black thing, soot, S-O-O-T. Okay, you take this, if you take this filter paper here, and take this filter paper here, all right, this one produces, because the higher percentage of carbon for alkene, so there will be more soot here for this, more black thing here. Here compared to here, it will be less. They give like that. But usually in SPM, they give like a circle. They put a dark circle here, they put a dark circle there. But the circle, the diameter of the circle will be more for alkene compared to diameter of the circle here. Like that. Can you see now? Okay. So compare the sootiness first, 2 marks. Okay. Okay. I want you to do a calculation, You take out, because whenever they ask you to compare, they will give you the relative atomic mass. Faham? Okay. We'll do a calculation now. Okay. So butane, carbon is 12. Hydrogen is 1. Okay, you're going to work out the percentage of carbon for me in both. Okay, percentage of carbon. Write it down first, by mass. You always ask this in SPM, by mass. Okay, let's work out percentage of carbon. Okay, let's try. This is C4, of course, remember the chemical formula. This is C4H10. Okay, kita tulis ini, Okay, so 12 times 4 is 48. Divide by the RMM for butane is 58. Times by 100%. Okay, work out the percentage for me. 100%, Okay, here for butane will be C4H8. Okay, so this one percentage of carbon also, percentage of carbon. Here it will be 12 times 4 is 48. This is butane, it will be 58. 48 plus, no, 56, sorry, 56. 48, okay, 56 times by 100%. Okay, work out the percentage and tell me. Yes. Joshua, give me the first answer for butane, please.
The mass, is it?
No, percentage. You times by 100%. So I'm working percentage by mass, Can you see now?
82.76.
Okay, 82.76, Very good. Okay, 82.76%. Okay. Jain, do the next one for me, Jain. How much you got?
85.71.
Okay, 85.71. See, they always will give you the relative atomic mass. When they give you REM, that means you're going to calculate. Okay. So now we compare. So you see, this is a higher percentage of carbon. So the smoke will be more smoky, So compare the sootiness, means the smoky flame. So Butene produces a more smoky flame compared to butane when burnt. B-U-T-E-N-E. Butene produces a more smoky flame compared to butane when burnt. This one you're burning, huh? So when you come back, I can show you in school. So we have, but I'll use hexane and hexene, huh? Both liquids. Any questions? So this is another way we can Bezelkan between alkane and alkene. One, we can use bromine water. Second one, we can use acidified potassium manganate 7. Okay, this is a third test. Whichever produce more smoky flame, that is an alkene. Compared to the alkane with the same number of carbon. Okay, faham, huh? Clear? Go next page. Okay, another flow chart.
Teacher, sorry, what's the explanation of it?
Explanation, huh? Put down. Okay, we have already calculated. So put down butene produce. So they say compare the sootiner. I mean, which is more smoky flame. So put down butene produces a more smoky flame than butane. That's 1 mark. They ask you to explain. Okay, so butene, E-N-E, produces a more smoky, S-M-O-K-Y, smoky flame, asap berjelaga they call it, than butane. What's the reason? Write it below. Butene has a higher percentage by mass of carbon. I want to see that word, the higher percentage by mass of carbon compared to butane. Butene has a higher percentage by mass of carbon. They want to see that word. Please highlight that word, higher percentage by mass of carbon compared to butane. When you want to compare the amount of percentage of carbon, it must be the same number of carbon. Hexane, hexene, butane, butane, like that. All right, that's how they give the question. Okay, it's actual number 4 now. Huh? Okay, you got another 5 more minutes. I think we can. Okay, let's try that. Another flow chart. Okay, this is ethene. I zoom in. Huh? Okay, ethene. Wait, where is it? Oh, sorry. Okay, let's try that. Huh? Ethene. All right. Process 1. Okay, we will write the name of process here. Okay. Ethene to ethanol. So it's process 1 is hydration. The 3 conditions, remember? Three conditions. Okay, write down the 3 conditions also. Temperature 300 degrees Celsius. Pressure 60 atm. What's the last one? Alim, what's the last condition for hydration? Alim? Anyone? This one?
Process 1.
Process 1. What's the one more condition? Temperature.
Wait. The aluminium powder.
No, lah. No.
No.
The catalyst. What's the catalyst?
Aluminium oxide.
Oh, the catalyst, not aluminum oxide.
Or phosphoric acid.
Phosphoric acid. Write it down. Temperature 300 degrees Celsius. Pressure 60 atm. Just put down here. Okay, catalyst phosphoric acid. I've given it before. PHOS, PHORIC, phosphoric acid. Okay. Then ethene undergoes polymerization. Can you see that? So compound P, put a note here. They gave you the process. They put polyethene. One word, C2H4 is ethene. Okay. Then we go like this. This one you take alcohol. This propanol, correct? Undergoes process 2 to become, this is propanoic acid. Can you see that? 2 plus 1 is 3. So this is process 2 is oxidation. Okay, process 2 is oxidation. We use oxidizing agent, like acidified potassium dichromate 6. Okay. Then propanol undergoes what? Becomes propene. This is dehydration. The special test tube we put horizontal dehydration. Okay. Now you can answer the question. Name process 1. So process 1 is hydration. They ask for name, give me a name. Okay. Draw the structural formula of C2H4. This one is, I see, polymerization. Shall we try? Okay, you try now in this box here. Okay, we'll try it, Okay. So this must be the monomer lah, Okay, isn't it? All right. So ethene first. No. I told you, for polymerization, you don't put the H on the side. You put the H will come on top. The right side, left side must be kosong. Put your H here. Put your H there. H, don't forget that. Huh? Okay, polymerization. So polyethene, okay, same thing. The only thing, the double bond is broken. Okay, and then the H, you come here, you put the H here. Okay, you put a long line, draw quite a long line like that. Yeah, Padam, this one, line you must. Okay, I do it again. Okay, carbon is here. All right, the line make it a bit long, and then you can put a bracket. Put a bracket like that, and you put an N because it's a polymer. This one don't need to put the N. You want to put an N also can, doesn't matter. But the N will come here. This one, the N will come here. You are just drawing ethene only. We're not drawing the monomer. Understand? But the monomer is ethene. Whatever you can put N also, I will still accept. Okay, name process 2. Okay, draw it first quickly. Don't forget your H, This one they can ask, explain. Okay. Okay, I continue. All right, Apadama. Okay. Name process. What's the next thing? Name process 2. Process 2 will be oxidation. Okay, write down first. Process 2 is oxidation. A very famous one. Oxidation was the color change, orange to green. Okay, color change, orange to green. All right. Name the product formed from the dehydration. So dehydration of propanol becomes propene. What we did just now, the drawing, the special drawing just now, propene. Okay. Okay, then esterification. Okay. Process 1 is process 1 is ethanol. Okay, and then this is the products from process 1 and process 3, process 2. Check one. Okay, this is ethanol, and this one is propanoic acid. Ethanol plus propanoic acid. What is the name of the ester? Anyone try? Satish, give me the name of ester. Ethanol and propanoic acid. What's the name of the ester?
Ethyl propanoate.
Well done, ethyl propanoate, isn't it? Okay, they asked for the name of the product. No. Here, name the process is esterification. 1 and 2 combined, sweet smelling. You saw that? Esterification. Okay. So ethyl propanoate. Okay, before we draw structural formula, all right, we will draw the molecular formula first. Baru, okay. Ethyl comes in behind the ester. The back of the ester is ethyl. Propanoate is 3 carbon, inclusive of the COO. Okay, so COO is 1 carbon here. So Baki will be C2H5. You see that? Okay, now let's draw that now. They didn't ask for this. This is molecular formula. Note it down, This is structural formula. Okay, so 1, 2 carbon. Okay, this C2H5. You draw that first. The one I did already. COO. Okay, put dash there, then put COO. Jaden, what's the name for COO, Jaden? What's the special name for this group?
Carboxyl.
No, carboxylate.
Carboxylate.
Carboxylate. COO is carboxylate. That's a functional group. Okay, then put your C2H5 here. Okay, 1, 2, 3, 4, 5. Yes, that's all. Draw structural formula, you must draw. Yeah, so name, give the name. This is molecular formula, short form. I put MF, molecular formula. This is structural formula. You must show all the H. Any questions so far? All right, done, So you know how to, when I give you the name of alcohol and name of carboxylate, you can get the ester. Very popular ester, I'm telling you. Okay, all right. So can I continue? Right, so that's about all of today. Okay. It's almost 3 already. Okay. Any questions for today? So listen very carefully. I repeat again. I want full attendance for the exam. Okay. At sharp 2 o'clock, I'm going to start already now. At sharp 2 o'clock on Thursday. Maybe I give you a 2, 3, 2, 4 like that. Okay, I can give you about 3, 4 minutes allowed because you also have history, isn't it? Okay. So around 2, 4 like that, I'll start. I'll give you roughly about 1.5 minutes per question. Some you can even do within 1 minute. Just answer the question there. It will be rate of reaction and also until rubber vulcanization, all that. So previous night itself, what you do is you write number 1 to number 40 in a blank piece of paper with your name there and your class. Okay, previous night itself. So when I show you the question, within that 1 hour, 1 minute or 1.5 minutes, right, you have to answer the question. It's all multiple choice. Okay, so we will finish around 3 o'clock on Thursday, roughly by 3:30 or 3:40. That's a maximum 3:40. You must give me the answer. Submit the answer. I'll give you my WhatsApp number and also my email. You can send both. But make sure your name is there. And please don't go and put Marcus Dick Head Chong and all that. Please write the full name there. Not any. My Form 4 class, one floor go and put King something, you know. King Arthur the Great. I don't know who the hell is King Arthur. You know. Please write your full name there. Please. Okay. Any question for today? No problem. I'll be straightforward only. Nothing to worry. It's quite very straightforward. Okay. You can finish the 40 questions in roughly about 1 hour. No problem. Okay. So with that, can I call it a day today? Okay. All right. So we've done the final round of revision. Okay. Thank you. So you're welcome.
Thank you, sir. Thank you, sir. Bye-bye.